All right. Hopefully, I'm fixing my audio issues because I'm moving my microphone closer to me. We'll see how this works out. All right. So here's our first example. It's page 581, number 14. Let's take a look at it real quick. Right there. It's about archaeologists and the width, the breadth, whatever, of Egyptian skulls in 4000 BC and in 200 BC. See if there's a difference, essentially. In this one, we have some data, which is, helpfully already entered into the calculator for me. So when you're doing this, the first thing you need to do, go through and enter your data. That will be important. All right. So it's asking about a confidence interval. So we don't have a hypothesis. So cool. Model. All right, so we have our independence ones. They are random sample and less than 10%. Okay, so for random sample, if these were all of the skulls that we dug up, then okay, it's what we've got. We hope that's representative. We're hoping it's representative of the population and not, if we had the 30 skulls from the pharaoh's family, those might be better fed than the other skulls, kind of thing. So I don't know if they chose 30 skulls out of their collection of 500 skulls, then okay. We don't have a lot of information about where this comes from, but we should still think about it a little bit. Less than 10%. So it is certainly less than 10% of all skulls of Egyptians living in about 4000 BC or in about 200 BC. If we did this from the museum's collection, I wouldn't worry about that because we don't care about the difference between the collections. We care about the difference between the actual Egyptians living at the time. So that's that. Nearly normal. As I have the data, I can just look at it. Alright, turn StatPlot1 on, make a histogram for list 1, and zoom 9. Our sample size is 30. That looks unimodal and symmetric. Looks great. Let's look at L2. Zoom 9. That doesn't look as fancy, but I mean, I still don't see that it's not unimodal and symmetric. It doesn't look nearly as close. I don't think it's bimodal. I think with 30 we just randomly... It still seems plausible that this was drawn from a normal model, basically. So I don't have any problems with this. We're looking for skew or outliers, and I just don't see them. Maybe that one up there, but even that, probably not all that much. 144, yeah, okay. That's correct. That's supposed to be 144. Yeah. All right. So that's nearly normal. If you can draw the histograms, but show that you've looked at histograms. I have video evidence. You don't. All right. Now independent groups. So there's 30 in each. which is a little bit suspicious. That's when we have to think, like, were these paired or not? These were not paired, like, definitely. There's one group from 4000 BC and one group from 200 BC. It's not like we took the person's direct descendant. It's just these were 30 skulls we found that were dated to about that period. These are independent groups. All right, so to create a 95% confidence interval, let's go to stat and tests, and this is a 2-sample, not test, 2-sample t interval. We have the data here. So list 1 is list 1, list 2 is list 2. They're both a frequency of 1. And we want a 95%. Pooled is no. Alright, so a whole bunch of stuff here. Mechanics. See if I can get that in, not the light, whatever. Alright, so we did a 2-sample t interval. If you're using your calculator, it's important to write down what you did. Since this stuff wasn't given to us in the problem, we should, the degrees of freedom for sure. Okay, so 1 was the 4000 BC. That is 131.37. The mean of the 200 was 135.63. Okay, the standard deviation of the 4000 was 5.13. The standard deviation of 200 was 4.04. Alright, sample sizes are there. And then our interval is on top. So negative 6.655 to negative 1.878. So a negative value, what does that mean? It means your first one is less than your second one by that much. So our conclusion, we are 95% confident that the average skull width breadth, whatever, of Egyptians in 4000 BCE is between 6.655 and 1.874. What are our units here? Millimeters. Less than in 200 BCE. Yeah, so if you'd put 1 and 2 in the other way around, if you'd put the 200 in first and the 4000 in second, you'd have gotten those numbers, but positive. So you could also write this conclusion that it's between that 6.655 and 1.874 millimeters more in 200 than it was in 4000. That would also be a reasonable way to interpret it if you don't like negative numbers. You'll notice I don't have negatives there because we're using the less. So you can have the negatives there, but negatives, like, don't double negative here, because that will be wrong, essentially.